So this is one of my favorite examples, is to ask, does the sum from n equals 1 to infinity of n to the n over n factorial converge or diverge? These are both just two almost unimaginably large numbers you're talking about. If you imagine 1,000 to the 1,000th power over 1,000 times 999 times 998, etc. I mean, this is just an enormous, these are both just enormous numbers. And the fact that we have a test that can even give us an answer is kind of amazing. So let me show you how this works. So what we want to do is we use the ratio test, and we're going to calculate the limit as n approaches infinity of every place I see an n, I'm going to replace it with n plus 1. So this is going to be n plus 1 to the n plus 1 over n plus 1 factorial times n factorial over n to the n. So just to be clear, this is a n plus 1, and this is 1 over a to the n. Just multiplying by 1 over a to the n. And I'm not going to put the absolute values in because we can clearly see everything in here is positive, so the absolute value is just going to be redundant in this case. So this gives us the limit as n approaches infinity of, I want to group things that are like each other together, but I'm going to show you have to be a little careful about how you do that. So this is going to be n plus 1 to the n plus 1 over n to the n. So I'll group those kind of terms together. And then here I'll group n factorial over n plus 1 factorial. So I'm going to group those together like that. Now let's keep going with the simplification. So this is going to be, let's see how to deal with this n plus 1 to the n plus 1 over n to the n. You have to be a little careful because this is n plus 1. What I want to do is I want to be able to put n plus 1 and n together. What I'd like to be able to do is write n plus 1 over n and make that to the nth power. The problem is I'm missing something if I do that, so let me just show you how you have to do this. So in order to do that simplification, I have to write n plus 1 to the n times n plus 1. In other words, that's what n plus 1 to the n plus 1 is, because I've got n plus 1 to the n, and then I've got one more factor of n plus 1. And then on the bottom, I can write n to the n like that. For the factorial, we already know how to simplify that. That's going to be n factorial over n plus 1 times n factorial. So now I can write this in this way. This is going to be, let's see, n plus 1 over n to the n. In other words, that takes care of these terms here. And then I've got n plus 1. That's going to be this term. And these terms, these n plus 1 factorials are going to cancel, leaving me with another n plus 1 on the bottom, which comes from here. So that gives me the limit as n approaches infinity of n plus 1 over n to the n times the limit as n approaches infinity of n plus 1 over n plus 1. Now, this very clearly approaches 1. I think we all know how to simplify that. That's just 1. So the question is, it comes down to a question of what is that equal to? So let's simplify that. That becomes the limit as n approaches infinity of, this is going to be n over n plus 1 over n. So this is going to be 1 plus 1 over n to the n. Now some of you may recognize this. We did this problem earlier as a L'Hopital's rule problem. So I'd invite you to go back to the lecture on sequences where we calculated this type of limit. But you have to recognize this thing in the parentheses is becoming 1 plus 0, so that's approaching 1, and then of course the exponent is approaching infinity. So this is a 1 to the infinity type of L'Hopital's rule situation, where you basically have to solve this by by converting this expression into e to the natural log of this, thereby bringing the exponent down. I invite you to go back to the earlier video and review how to evaluate this limit. The point is that this limit is actually, it's going to come out to e. In fact, it's worth remembering that this expression, this limit expression, actually comes out to e, even though you should know how to calculate it. So since e is approximately equal to 2.72, which is clearly greater than 1, therefore we can conclude that this the series diverges. And that's the answer.